We are ready to start. Our next speaker is called Guillaume, so please welcome him.
So hi, I'm here to present you a GTK RS. It won't be a technical speak at all, so if you have technical questions, we can speak after the talk. So GTK RS, how to make unsafe safe. So first, what is GTK? So it's a GNOME UI library, very used in the Linux environments. So cross-platform, it works as well on the Mac, and as far as I know, it works as well on Windows. So, fine. So a bit of history. At first, it was started by Jean-Marie Letang in 2015. It was when we were both of us still at school. We started it to learn Rust. So first it was called LGTK, and we have subcrates for each GNOME library, like GIO, JLib, and stuff. It was all in the same repository, at the opposite of currently. So the first implementation was very simple. It was one-to-one binding. So you had a function, an object. It was the same in Rust. So not much advantages, but you could use a GTK in Rust. So now the cons. So yeah, it was at the time very slow to compile. We were still in 2015. It wasn't that. We had a huge macro to generate all signals. Wasn't very, very efficient. So since it was bound by hand, a lot of typo, human errors were there, casting errors. Yeah, just like I said, it was just a wrapper around C code, just one-to-one, not much safety. And at the time, the compiler was getting updated and having breaking changes like every 2 or 3 days. So changing the thousands of lines at once was quite long for a library this big. So I think it was at the start of 2016. We had a new contributor. We brought the GEAR support. So GEAR is a format which is used by the GNOME libraries to describe your API, and is used by other languages to generate their OR binding. And that's what we did in Rust with a whole new crate, GEAR, which generates all the code. So that's the first thing we did. We also rewrote all the glib. How to explain? The glib is the base, and we had to rewrite it in order to make it work to build upon it. That's it. So, and so we did that. We could bring a whole new trait system. So now you can say if an object inherits from another. Very helpful. It does prevents from casting from a type to another. So that's it. And another thing which I think it's still a bit of a debate, but we decided to split libraries into their own repository. So now glib isn't in GTK repository anymore. It's the same organization, but not the same repository, which has its issues for every release. That's a debate. So the new trait system is basically based on this one, is L. So now when you have a function, for example, for the widget, you take is a widget. So every object which implements this trait can be used in this function. So now, why is it better to use GTK RS over GTK directly? For a few things. So, like it's written, let's start with compile errors type conversions. So in C, you can totally do that. It's not a problem, not much checks. In Rust, you will do it with by using the upcast method. The big difference being, well, at this point there isn't much. It's just in Rust we have checks done at compile time. So here, if you try to make an invalid cast, it will just segfault when you run it. So it's inconvenient to discover there is an error in your code after being compiled when distributed. And in Rust, if you try the same, casting a type which isn't a children of a window. For example, a button is a children of a widget, but isn't the children of a window. If you try it, you won't compile. You will get an error. So the trait isn't implemented for a GTK button. It's quite convenient. So yeah, another advantage, of course, is the code readability. So in C, very verbose. In Rust, a bit less. It's the advantage of object-oriented languages. Not bad to say in here. So some other gains. So there are quite a lot brought by Rust directly. Automatic referencing and memory management brought by the Rust compiler directly. The sync and send trait bonds, which are used for signals, for example. So like that, you're sure your object won't be destroyed and called while being after being destroyed. Makes sense. And we enforce when we generate the API that if you want a string or pass, which is very convenient when you have to open a file or to specify a title to be sure you won't try to do something strange at best. So, like I said above, everything related to closure, so signals, callbacks, everything. So yeah, some other gains, of course. Now you can't have arrays which have invalid size. You can't give, we don't allow to give a size of an array when you give it to a function. It's done. An array is a 5 pointer, so you have its length provided by the type directly. So no need to give the size anymore. Very convenient and allow to have a lot less errors. And of course, the strong type system, which is one of the biggest advantages of Rust. So you can't make a cast however you want, just what the function needs. So now at this point, what remains to be done? Well, I think we are around 90% of bindings automatically generated. And most of missing functionalities, functions, objects are clearly in GIO. So I'm starting to write new things in it directly. We'll see how much time it takes. Hopefully a few months, don't know yet. We started recently at the last GNOME Rust Hackfest to improve the asynchronous support, which is very asked by a few people, so it's coming. And of course, from now, the documentation is generated at the same time as the API. So we directly have a C documentation, not Rust one. So examples are in C, a lot of things aren't perfect. We have still a lot of work to do in there. So it will be the next step, I think, once we are done with the bindings. So beyond the GTK-RS, so we had a few people from the GNOME community very interesting in Rust. We started a few Hackfest last year about this to write the GNOME class project, for example. The previous talker is from GNOME and yeah, highly. There is Federico, a big guy in GNOME, which is rewriting a library, lib_rsvg, in Rust directly. Yeah, I think that's because of him we started the, yeah, I think, yeah, it was for this. And of course, yeah, we have other GNOME libraries which start to have a binding, so JStreamer from, I don't know where he is, but yeah. We have a WebKit to GTK, and source view and a lot more, so. As long as it has a gear file, basically you can generate it automatically. I don't know how it goes for JStreamer. I think it's mostly wrote by hand. So now we have achieved a good level, I think, at this point. We don't miss much. We are on little details now, having a deprecation, having more dogs, having a better interface, better errors. And at this point, how could we do to make it even better? And Realm has been created for that. It's another abstraction level, so I will let its creator speak for it. So I give you the mic.
So, as Guillaume said, Realm is an abstraction over GTK-RS, which provides a more idiomatic way to create desktop application in Rust, and it is based on GTK-RS, and it also provides some support for asynchronous programming. So first I'll cover some pain points I had when working with GTK-RS by developing a web browser. So the first problem I had is when you want to associate some data with a widget, let's say the model of your application. When you want to do that with GTK-RS, because of the safety we had in Rust, we need to use an RC ref solve. So we have a ref counted value that we want to check be able to borrow, check the borrow at runtime. So we need to use this boilerplate code with borrow, mat, and borrow when we want to update the model in a signal, which is something we want to do somewhat frequently in GUI applications. So that's not very ergonomic. It's error prone because we only get the error at runtime instead of at compile time. So one thing I wanted to tell you is that if you can avoid using refsol, it's a good thing to avoid. And what I do in Realm is that I use a refsol, but I'm just not telling you. So also you can do asynchronous programming with glib and stuff, but it's not very ergonomic. And I wanted to integrate Realm with the asynchronous I/O library in Rust, which is Tokyo. And also, since Rust does not provide inheritance, you cannot do, for instance, like in Vala, declare a new class deriving from an existing widget to be able to use this new widget like any other widgets. So that's not possible in Rust. So I wanted to, with Realm, be able to declare new widgets that could be used the same way as the GTK widgets. So Realm is inspired by a language that is called Elm that is used for developing client-side applications. So Elm is an alternative to JavaScript. I found out it provides a good way to do model view controller. So that's my main inspiration for Realm. So in Elm, you will declare a model, which is the data that you associate with a view. And you have an update function that would take the model in response to some event and return the new model. And you also have a view function that describes your view in a declarative way. In Realm, I use that, but I adapted it to Rust. So, for instance, update and view are now methods of a widget trait, and we use mutation when it's convenient. For instance, the update method will take self by reference so that we can mutate the model instead of having to return a new model. So let's see how we can use Realm. First, we need to declare a model, which is a normal type in Rust, so it could be a struct. And then we use this widget attribute on an impl of widget, which is the trait we want to implement, and for a window in this case, which will create a window. So we need first the model method, which declares the initial model of your widget. And then we have messages that are used to communicate, for instance, between widgets or having a message chain when there's a GTK event. And it can also be used when there's asynchronous I/O. So for instance, you do a network request, and when it's done, you receive a message. So we use the custom derived message, and we have an enum, which has many variants that can have a value. And then we have the view. So it's still in the impl widget, and we use the view macro, and we now have this declarative syntax. So we can create GTK widgets and nest them, and also set their properties. We can connect the click event, for instance, which will send the increment message in this case. And we can also do bindings, meaning that at the last line we have the text property of the label that is bound to an attribute of the model. So that means that whenever this attribute of the model is changed, that will update the view. And then we have this update method. So it takes self by mutable reference, which has access to the model that we can modify when we receive a message. So in this case, when we receive the decrement message, we just change the counter attribute of the model, and that will actually update the view, even though it's not shown here. So how does all of that work? So the widget attribute will start by collecting the data binding. So it will analyze the view, check that in this case the label has a property that is called text that is bound to the counter attribute of the model. And then it will actually change the code you wrote in the update method to actually update the view. So it will see here that the counter attribute was changed, and it will use this value to update the view because it noticed that there was a bending in the view. So even though I use attributes, run can work on stable ROS because I use a hack to have the procedural macro to work. And the future of run will may be without filters. Also, I will work to improve the error messages because at the time I first started run, it was using the old SYN crate. So we didn't have access to the position of the token. So that's why when you have an error message, it's shown on the widget attribute, which is not convenient. And I will support more GTK features. So do you have any questions? Yes?
I have a question about another sprint. So you said at some point that Rust checks array lengths. Compile time.
Sorry.
You said Rust checks array lengths at compile time.
Yeah.
Can you go into that a bit? How exactly does it do it?
So the question is, I will take this one. So the question is, how does Rust checks the length of arrays at compile time? It's slice. It's basically an array in Rust is a slice. So in the type, you have the pointer where it starts, and you have its length in the same point. It's what we call a fat pointer. So when we give it to a function, when we generate the code, we just know the size of the slice. You can't cheat. When you create a slice, you know its size. You can't. It's constant. So when you pass it to a function, obviously you know its size, and we can give it to the GTK function. Is it okay? Other question? Yes.
You mentioned that you're planning to implement asynchronous interface for DIO. Will this be based on features, or what are you planning to do there?
So the question is, do I intend in GIO to use Tokyo for async? That's it.
To use futures.
Yeah, futures. So I don't really know. For instance, with Anthony, we talk a lot about how to do asynchronous stuff, and I think you will be the best to answer this one, actually. Yeah.
Yes, so in the Hackfest we had, I implemented the code generator, the stuff to generate the asynchronous method, and for now it's just working with callbacks. So for now there's no support for features, but that may be added in the future. No pun intended.
I have one more question.
Yep.
I wrote a binding for a library, like GD-based library in the Hackfest. I found the process a bit tedious, like it took me a few days to get it working. Is there any plan to like make it easy to add like bindings to existing libraries?
So I repeat the question. The question is for the gear generator for now. He asked if we intend to make it simpler, because I didn't talk about that, so I will go into details a bit. The gear generator first generate a low-level API, which isn't supposed to be used directly by the users, and then from this, it just writes the functions from and all the time the types from the libraries, and from this you can how to say, we have another level which is used directly. And it provides the API which calls the functions bound by the low level, if that's clear. So at this point, it's a bit complicated if you don't know how gear works. Well, even if you know, it's a bit. So we intend in the few more weeks to make something better. But it's more like when we have someone new starting a new library using GIR, we take what it says is missing. So that's why we wrote this huge README file. And then we add new elements, and maybe someday I will write a guide or something in order to avoid, to just allow more people to have their own libraries if they want. Yeah.